All right, just remember as you guys go through this that this is all about the week 10 and 11 review. We're starting the review for the final. So for the final, you need the third packet. So this final review, you need this third packet. You can find this again at the library. Here's the hours right here. I post it wherever you guys see your packet assignments. But basically, the review for the final is in the third packet. It's in the very back. So as you kind of flip through, get to the back, you'll notice it starts with week 10. And it basically, there's one page, and you can see right here, there's one page for every week. So right there, there's week 10. Page right after that is week 11, which is the ones we're going to go through, week 12, and so on. Okay. So have your pen ready. And you're going to do all these notes in your notebook, but basically I'm going to be going over these problems starting with the factory. Okay. All right. So first we're going to start with GCF. Okay. So GCF, let's say I've got 3r cubed plus 15r squared plus 24r. All right. What I want to do for GCF is I want to look for a common factor between all my terms. So first I look at the coefficients, the numbers. I say, okay, 3, 15, and 24. What's in common? Well, 3. Then I look at R variables. R cubed, R squared, and R. What's in common? Well, they all have at least one R. So I put an R right there. Okay, now I need to factor out that 3r from each of these terms. So now 3r times what gives me that term? Well, r squared. 3r times what gives me that term? That would be 5r. And then 3r times 8 gives me that last term. Okay, and that's it. The other thing I want to double check is see, can I factor r squared plus 5r plus 8? Can I use the diamond and see if I can factor that? It's two numbers that multiply to 8 add up to 5. No, nothing works. Okay, so your problem that you're going to do is 4x. Actually, let's do to the fourth power. Actually, we'll do the same. So cubed plus 8x squared plus, let's say 32. 32x. Okay, let's go ahead and do that one. Okay, so for our next problem. Okay, so now we're going to focus in on what's next. Another GCF type of problem. All right, so now let's say I've got 2r cubed, okay, plus 10r squared minus 28r, right? Okay, I do the same thing. I look for the greatest common factor, the GCF. 2, 10, and 28, the common factor would be 2. Between r cubed, r squared, and r, the common factor would be r. And I factor out the 2r from each of those. So here I'd have r squared. Here I'd have 5r. And then here I'd have minus 14. And again, I want to check, okay, can I use the x to factor this out? Okay, so negative 14, r squared, positive 5. Two numbers that multiply to negative 14 add up to 5. Well, that would be 7r and negative 2r. So that does work. So I can factor this. All right, now remember, if the first number in your trinomial is 1, I don't need to do the box. So I'm going to go straight to my factors. Now, if it's 7r, that means I put r plus 7. If it's negative 2r, then I put r minus 2. The thing you need to remember is that don't forget to bring your GCF down. That is a part of the expression. Okay? And again, all we're doing is factoring. So don't try to solve this and write this as like r equals negative 7 and blah, blah, blah. That's not what it's asking for. It's just asking you to factor the expression and rewrite it. Okay? So the one I want you guys to work on, let's go 3 r to the fourth plus, let's do 21 r, and then plus 30. Okay, so r, and I apologize, I want r cubed there and r squared there. Okay, now remember, this one has a higher degree of r's, so here I could factor out more than just r. I could factor out, you got to look and see how many r's in common. How many does each of these have at least? Okay, and I'll give you guys a little hint here. The common factor is 3r squared. So factor out that 3r squared from the rest, and you will have to do a diamond and factor the rest out. Okay. Okay, now let's go down to where it says difference of squares and sum and differences of cubes. First, we'll do a perfect square type problem. Okay, so if I have a perfect square, let's say 4x squared minus 25. Okay, almost a lot like the other one you just saw. Okay, so here, remember, if these are two perfect squares and it's a difference, meaning they have minus, I can go straight to these factors. I square root the first and the second number. The square root of the first term will be your first term in each factor, and the square root of the second term will be the second term in each factor. And then remember that your signs would be, one would be plus and the other would be minus. Okay, now let me take that same problem and let's do this. I'm going to make it 8x squared minus 50. Okay, well now 8 and 50 are not perfect squares, but what I do notice is that there's a greatest common factor, or there's a common factor of 2. So I can factor out a 2. As a matter of fact, let's take it a step further. Let's make this x cubed and this x, right? So now there's a common factor of 2 and there's a common factor of x. I factor that out. Now I have 4x squared minus 25. And now it's literally the same thing over again. All right, so now I'm going to do the difference of squares. I get the same factors. The only difference was that I had to find a GCF first. Okay, what I want you guys to do is let's do 18x cubed minus we'll do 32x. Okay, so that's the one I want you guys to factor out. Find a GCF, goes there, and then factor it out using the difference of squares. Okay. Okay, so now sums and differences of cubes. So now let's say I have 8x cubed minus 27. Well, neither of these are perfect squares, but they are perfect cubes. Numbers that where I can multiply one number 3 times to get that number. Whereas the last ones like 4 or 25 or 16, these are numbers where I can multiply a number twice to get that number. Let's say I can multiply 2. Here I can multiply 5. Here I can multiply 4 or 6, right? But here, these are perfect cubes, which means I can multiply a number 3 times. So for 8, the cube root of that would be 2. Cube root of 27 would be 3. All right, so how we do this? All right, well, first, I got to identify it's a difference of cubes, and I got to know this formula. So A, now if it's minus, this will also be minus. And the first factor, you'll do A minus B. And the second part will be A squared. If that's minus, this first sign will be plus. And the second term here will be A times B. And then the third term will be B squared. But the first step you got to do is you got to find the A and B and then plug it in. Okay? The way you get your A and B is you take your first term and you cube root that. Find the cube root of that. And do the same thing with the second term. I cube root that number. The negative doesn't matter because we're going to account for that here. So don't worry about the negatives. So first of all, what number do I multiply 3 times to get 8? Well, that would be 2. And then I also have to count for the x. So x times x times x, or 3x's, equals x cubed. So it's 2x. That's the A. The B, what number do I multiply 3 times to get 27? Well, that would be 3. Okay, so to finish this up, we're just going to basically plug those values in there, right? So now A minus B, there's your A, there's your B, 2x minus 3. Then it's A squared, so that means that A squared means that I'm going to square both the 2 and the x. Okay, if I'm going to square the 2 and the x, that means it's going to be 4x squared. Okay, the next sign is plus. Then A times B, 2x times 3, 6x. And then now B squared, so 3. All right, and then that's it. All right, the one I want you guys to do. And again, always look, is there a GCF that I can factor out first? There isn't one for this one, but sometimes there is. All right, the one I want y'all to do is, let's do 27 y cubed minus 64. Okay, so now on the next one here, we got factoring by grouping. All right, so now factoring by grouping. All right, next thing we're going to go over is the next page, and this is all about roots. Now, this is just get this. These first two are just about sketching, but what we're focusing on is right here. These ones where it's asking, what are the roots? Okay, so let's just say I've got y equals x squared plus 7x. You might recognize this from one of the problems you just did earlier. And it says, what are the roots? Okay, well, in order to find the roots, essentially what we want to do is figure out when is this equation equal to 0. So I could write it like this. Just set it equal to 0, right? And then what we want to do is we want to factor it out if possible. Okay, figure out what those factors are, and then we'll come up with the roots. Okay, so what I'm going to do here is just set up our x. Here we got 10x squared. Here we got 7x. What two numbers multiply to give me 10? Add up to 7. That'd be 5x and 2x. Remember, again, this has a coefficient of 1, so that means I can write the factors directly in there. And now it's actually asking me to solve and find the roots, so I am going to take it a step further. So now this would be x equals -5 and -7. So those are my roots. Okay, so the one I want you guys to try is y equals -7x, and we'll go -18. Okay, find the roots. Okay, so, and if you're looking at this second equation, it's pretty similar. You're doing the same thing twice there. Okay, so now this next one, you are looking for, given a set of points, write a possible equation. All right, so write it in standard form. Okay, standard form, it's important to know because we want to be able to work this out fully. Okay, so if it's asking for an equation in standard form, write these up here just as a reminder. Okay, what it's going to give you is either like 2 or 3 or 4 different x-intercepts. It might even call them roots. And I'm going to give it to you in all the different forms just so you guys know, and it's all the same thing. Right, so let's just say that it gives you the x-intercepts of 2 and -3, 0, and also, let's say, 5, 0, right? Okay, so if those are the x-intercepts, I'm going to write out an equation. Now, it could say this. It could say the roots are 2, -3, and 5. Or it could say the solutions are x equals 2, x equals -3, and x equals 5. That is literally the same thing written 3 different ways. Okay, so it is not different. All right, so what I do is I'm going to start with f of x because I'm creating an equation, and I'm going to write all of these out in factored form or as factors. So if this is positive 2, that means my factor will be x minus 2. If that's -3, this will be x plus 3. And again, that's positive 5, so this will be x minus 5. All right, so now what I got to do is I need to put this in standard form because this is factored form, which means I need to multiply all this out. Okay, so what I'm going to do is I'm going to multiply these out using the box. So x minus 2, x plus 3, x squared, -2x, 3x, minus 6. So that one's going to be x squared plus x, because I'm adding up those two there, and then minus 6. Okay, now what I got to do is multiply these two together. And to do that, I'm going to do a 2 by 3 box. So first I put the x minus 5 here, x squared plus x, and then negative 6 here. Okay, that's x cubed minus 5x squared. That's x squared. That's negative 5x. That's negative 6x. And that's positive 30. Okay, so start with x cubed. Then I'm going to add negative 5 and 1. So that'd be negative 4x squared. And then negative 6 and negative 5. So that'd be negative 11x. And then plus 30. And then don't forget to start it with f of x. All right. So that's how we do it in standard form. Now, what if it asks you to do it and it includes a point? Well, that means you need to write an accurate equation, right? Okay, well, that's a little bit different. Okay, but before we do that, I'm going to erase this, but you can always look back on it to figure out the problem I'm going to give you. Before we do that, what I want you to do is figure out the equation for 3, 0 and negative 5, 0. And notice I only gave you 2, so that means you're only going to have 2 factors. Okay, so go ahead and find those factors and write it out in standard form. Okay, now let's take this problem a step further, right? And now let's say that not only did it give you the x-intercepts, but it also gives you a point. And let's just say that other point is 0 and 2. Okay? In other words, that's a y-intercept, but it doesn't really matter. It could be any point. All right? If it's asking for an accurate equation, and actually, you know what I'm also going to say? We're going to also say that at negative 5, it bounces. If you guys remember what bounces are, oops, I'm totally spelling this wrong. It's when a graph looks like this. Let's say it crosses through at 3, right? So 1, 2, 3. Crosses through at 3, and then somehow comes down here through 2, and then 1, 2, 3, 4, 5, and then it bounces here at negative 5. Okay, so if it bounces at negative 5, that means it's a double root. All right, so let's write that out. So first, again, if we want an accurate equation, I write a, and then I'm going to write, because I have to find this a value. Okay, when I'm looking for an accurate equation, first I write the factors. So I got positive 3. I wrote x minus 3, negative 5, plus 5. Now what I'm going to do is take this point that they give me, and sometimes that point's not just 0, 2. Sometimes it's something else. Like you can see here, you guys have 3, negative 12. All right, so now I'm going to plug in the 2 for the y, because that's the y value. And then I'm going to plug in the 0 for the x value. So if you do have an x value other than 0, you just have one little extra step of work there. Since mine's 0, it just makes it a little simpler. All right, so then 0 minus 3, 0 plus 5. Now what I do is I multiply those two, and I get negative 15a, and then divide by negative 15. And then there is my a value, but I'm not done. I got to write out the equation now. Y equals my a value. I'm basically just plugging it in there, of negative 2 over 15 times, now I just rewrite those factors. Okay, and that's it there. And I think what I'm going to do is I'm going to go through and change this problem just a little bit, just so it's a little bit easier for you guys to understand here on how to do yours. I'm actually going to change this y-intercept, and let's make it 15, right? So if that's 15, that means I just change this to 15, this to 15, this also to 15. And now when I divide these two numbers, it's 15 divided by negative 15, which means that a equals negative 1. So now when I plug in negative 1 here, all right, I have negative 1. But remember, it says write in standard form, which means I need to multiply these out first. Right? So I'm going to multiply x minus 3 times x plus 5. Well, I'm just going to FOIL squared there. Then plus 5x. And then inside minus 3x. And you can also do this with the box. Same thing. All right. Now let's add up those like terms. These two in the middle. Be plus 2x and then minus 15. And this negative 1. If it asks you to do standard form, that means I need to take this a value down here and I need to distribute it to each term. So here I'd end up with negative x squared minus 2x and then plus 15. Basically multiplied each of those numbers times negative 1. Okay? All right. So here's the one you guys will do. This is your last problem you're going to work on. You will have 4, 0, and 3, 0 as your x-intercepts. And then the point that you are going to plug in is going to be 0 and 24. Okay? So I want you to set up, actually we'll do it with y. Remember to set these up with your a value and your two factors. Then you'll have to multiply these two out. Actually, don't multiply these out. Then you're going to need to plug in your point, solve for a, and then plug the a in, and then you're going to have to simplify these two. Rewind the video if you need to by doing the box, and then distribute your a value to get it in standard form. All right?